after tip replacement, where the tip has moved, I could use the micrometers to recenter the tip to a memorized position. There are several advantages in utilizing this design. The AFM tip can be inspected and aligned by a very high quality optical microscope that already exists in the system. AFM works similar to an electron microscope, except that instead of using a finely focused electron beam, it uses a sharp stylus attached to a spring cantilever to scan the image. A laser beam reflects off of the back of the cantilever to measure its interactions with the contours of the sample. The optical microscope and the AFM are built into one workstation, and there's a motorized stage that transports the area of interest directly beneath the AFM. If I go back to the optical, you're able to view the sample again. One of the problems with such system is when you change tips, you have to remove the AFM head and replace the tip. When you put this back, the original position of the tip has been lost. We have invented an alignment tool that eliminates tip alignment procedure. It utilizes a relay optics that projects an image of the cantilever tip beneath the focal point of the microscope objective, allowing the microscope to center the tip using a crosshair. And when the tip is replaced, it is brought back to this memorized position. Let me show you here. I'm going to rotate the tip 90 degrees, and basically I'm going to bring it back to center. And the tip is aligned. If I decide to go back to previous orientation, I can bring back the tip to its original position. The way this works is we have an XY stage here that allows me to do the pre-alignment. So the original position of the tip is always aligned. We have chosen the center of the chalk for our reference point. If you look at the background, you can see the AFM tip. At least a third of the price of the whole system is invested in the optical microscope. It has illumination, it has DIC control, differential interference contrast. It's a very high quality microscope, necessary because defects are very small today, and you need the maximum quality possible in finding the defect before transporting it beneath the AFM for scanning. So I have a tip here on the screen produced by the relay optics. I can change magnification. I can change the contrast if I want to view the tip. I can go higher in magnification. Immediately I can center the tip. You see, when you change magnification, it is important that you use the adjustment on the alignment tool, because the tip position hasn't really changed. It's just your optical center has changed. So, but when you take off the tip, you use this upper micrometers to position, to center the tip. As you can see, all these functions are available. So if I want to go back to the 20x magnification, again, I'm going to use this micrometer and the alignment tool to memorize the position of the tip. Another advantage of the alignment tool is that my approach distance to the sample for the AFM can be predetermined. As soon as I'm focused to the tip, I have the correct minimum approach distance. I know there are other systems that use a side camera to view the AFM tip as it approaches the sample. The main advantage of this alignment tool is it saves time, allows the end user to try various tip angles without fear of misalignment. It utilizes the same optical microscope to view the tip condition and be able to change magnifications and to use all the features of the optical microscope. I hope you will try this tool that we have, and it will save you a lot of time and money.